I welcome you all again to this physics session. I am Dr. Suman Bhatnagar. I'm a faculty member at Prepaze, and today we'll be continuing our discussion on the work power energy. And just before starting, I would like to introduce to Prepaze. So Prepaze is an online platform where you can find faculty members and experts like me in different topics, in different subjects. Whichever topic or whichever subject you are facing difficulties, please do check the website, book a free trial class with your tutor. Try to get maximum benefit at the comfort of your home. Start today's session and continue our discussion on work, power, energy. Work, power, and energy. So last class basically discussed about the work and the energy concept, and I told you about the conservation of energy principle, right? Today, let us do more a bit of more questions only on the conservation of energy because that's very important topic. So we will be discussing question on conservation of energy. Now, the very first and the basic idea of the conservation of energy, let us discuss in an inclined plane problem. So suppose I have an inclined plane problem like this. If I tell you, suppose, let's say this is theta angle given, the length of the incline is L given to us. There is a block of over here of mass M, let's say. There's a block of mass M kept over here. It is initially dropped from this position, that is initial velocity V naught is equals to 0. It is dropped from this position. Obviously, it will come down over here. And this is frictionless right now. It is frictionless. It will come, this block will come over here after some time, and it will definitely have some velocity. Now, obviously, this question can be solved with the equations of motion, but I don't want to do that. If you have knowledge, please try to solve this question by work conservation of energy principle and try to get the answer. How to solve it? Let's see the situation. Suppose again, I will mark 2 points A and B. What is the energy at A? Energy at A is basically equal to mg h. It is not L, it is h, which is a vertical height. We always take the vertical height from the ground. This is the ground, let's say. Now we have L and theta, but we don't have h basically. So what we can do over here, we can use sine theta value. So sine theta is what? Sine theta is equal to h over L. So it implies h is what? L sine theta. We will be using this h over here. What is the energy at B? Energy at B, again, gravitational potential energy is what? 0 because it is on the ground. So it will have only kinetic energy, which is half m into v square. And according to conservation of energy, what we have to do? We have to make these two energies equal, right? That is basically mgh will be equal to half mv square. What is h? It is L sine theta. So m first of all cancel out. What is g? H is L sine theta equals to, this is what, v square by 2. So what is the velocity? It is under root of 2gl sine theta. See, the question becomes extremely easy when we use conservation of energy. Now, see, you can use this equations of motions also to solve this question, but it is not always applicable, right? Equations of motion. You can use equations of motion only when the acceleration is constant, not always. So, but this conservation of energy idea, this principle, it is always applicable. So always whenever a question which involves such things like the height, velocity, try to first use the energy conservation principle. So not always you can use this idea, right? I mean, the conservation of energy is valid, but the idea may not be valid for some questions. So that was about it. Okay, this is basically conservation of energy when we are talking on inclined plane and how to solve it. After this, let's move forward. So last class also we discussed the elastic potential energy, right? Elastic potential energy. Let us introduce this spring now also. Up till now, what we were doing, we basically was doing on the kinetic energy and the gravitational potential energy only, right? Conservation. Now let us introduce a elastic potential energy in the questions and see how basically we can use that. So let us discuss elastic potential energy questions. So the question goes like this. So over here, suppose this is a level ground and this, after this, basically it gets inclined at this angle theta. About this wall, okay, when there's a wall, there is a spring which is initially compressed completely. Okay, the spring is initially compressed completely, and there is a box or a block, whatever it is, okay, of a mass, let's say 2 kg, which is attached to it. After this, spring is just left, okay, where you just leave the spring. What will happen? Obviously, this block will go forward, and imagine at some position, let's say at this position, the spring comes back to its natural length, which is like this. This is natural length of the spring, At the natural length, block leaves the spring. Block leaves the spring and travels on a smooth surface, smooth surface, which leads to an inclined plane. The first part of the question, find velocity at the bottom of incline. And the second part of the question is max height attained or achieved. Height over here is this vertical height. Whenever we always denote by vertical height. All right, maximum height achieved, and what is the velocity at the bottommost point. All right, so these two things we have to calculate over here. Let us see how we can proceed with this question over here. So it is initially compressed completely. All right, so that means when it is compressed completely, so I will just mark first of all 3 points over here. That will be easier for you to understand. Let me call this is point A, this is point B, and this is the point C. We will talk on the level ground. On the level ground, obviously there is no gravitational potential energy involved. It's on the level ground, there is no height. The gravitational potential energy is 0. So I can say that the energy at A will be equal to the energy at B. Now, the spring constant, okay, I forgot to give the value. Let's say 500 Newton per meter, the spring constant, and the value of the compression, you can take it, let's say 2 centimeters. Okay, 2 centimeters, something like this. So now energy at A will be equal to energy at the point B. Is the block moving at A? Obviously, the gravitational potential energy is 0. We are not talking about that. So let's include all the basically variables, so it will be easier. So firstly we have elastic potential energy at A plus kinetic energy at A plus gravitational potential energy at A. These are the only 3 different forms of energy you can be expected a question of. Then if it equals to the elastic potential energy at B plus kinetic energy at B plus gravitational potential energy at B. Now, elastic potential energy at A, yes, there is. What is the value? It is half K into x square. Is there any kinetic energy? No. Is there any gravitational potential energy at A? No. Is equal to elastic potential energy at B. Now it is being given that at this position, basically the block leaves. So the spring comes back to its normal length. After this, it does not go anywhere. It just stays over there. So that means when the block will reach at B, the spring is at its natural length. So if it is a natural length, it is no compression, no extension. That means what? The velocity is 0. There is no elastic potential energy in that. So this is basically 0. Kinetic energy at B, yes, there is kinetic energy at B, which we need to find out. Velocity at B square. Gravitational potential energy is there? No, it is not. So that is half kx square. This equals to half mv square. So what is this? This is basically the velocity at B is equal to kx square by m and under root of that. Okay, that is the velocity. Now come back to B point of the question, which says that what is the maximum height attained? Now what you can do, you can forget about the point. You don't need that. Okay, you just think of the A point and C point, or you can, if you want to do by B, you can also do that. So energy at A will be equal to energy at C. So what is the energy at A? It is half kx square. We know that. What is the energy at point C? It is mgh. That's it. From h is what? Half k x square over mg. That is the value of h you will get from it. So you can just put the variables and check it. I'm not doing that. Just for your understanding, I'm explaining it to you how the question can be done so much easy. Now, if you're looking these questions for the first time and you are seeing what I'm just explaining to you, you might feel that it is easy, but it's when you are applying it on your own, for the first time, obviously, you might feel some difficulty. So obviously the best way, which I always tell, practice as much as you can, so that you can be aware of different concepts and different type of questions which can be asked. So this is like a one type of a question. There are thousands of questions can be framed on the basis of this idea. So obviously you're going to do all 1,000, but the basic idea should be clear. So that is basically when we are having a elastic potential energy also there. So this is basically the concept involved in that. Now let's move forward. So up till now, with all the questions which we discussed there is no energy loss. What if there is friction? Friction is there. Now what effect will friction will have? Think of an inclined plane problem which I gave you earlier. I told you, okay, let me give the height over here. Let's say this h, there's a block of mass m kept over here, and it is a frictional surface with some friction mu. Now this is angle theta. This blocks after some time, let's say it reaches over here. So the velocity, it is now being asked. Now see what is happening. Initially This is point A, this is point B. Initially, the block have some energy, which is energy at A, which is equals to what? mgh. Now, is this energy is equal to the energy at B? No, it is not equal to that. Why it is not equal to that? Because there is now a friction is there. The conservation of energy principle is still valid. It's not that it is not valid over. Okay, it is still valid, but there are some changes I told you earlier, so we need to apply. So it is not equal to the energy at B. What is happening over here now? Because of the friction, there is a heat generated. You can, this is obviously there is friction, right? You cannot have exactly the same energies overall. Okay? There is some heat involved. Okay, suppose this is very common example. Let's say you roll a ball on the ground. You give the some kinetic energy to the ball, but after some time the ball stops, right? Why it gets stopped? Because friction stops it. So whatever the energy you supply to the ball, it is taken away by friction. So you can think of this like this. So whatever energy supplied, some or all will be taken away by friction. All right, that is the energy at A will be equal to energy at B, but we have to consider also the loss of energy. There is some loss. So there is an additional term E loss which get introduced in the equation of conservation of energy. The energy is conserved. So now what is happening? From the gravitational potential energy, the energy is getting converted to the kinetic energy, plus you can think of it like a thermal energy where the heat is involved. Because of friction is what? Friction does the work on that. So there's a heat involved in this. So that is basically the idea of it. So what is happening now? We have to consider the loss. Now, how to find out the loss in this case? See, to find out the loss, we need to find out basically E loss is what? E loss is equal to the work done by friction. How much the friction is doing the work, that will be equal to the loss. In this given question, suppose let's say this is h. So what is this L? Let's say the length is L only. Okay, let's say the length of the inclined plane is L. The friction force is acting backward, which is F. What is the work done by force? Again, remember the formula. It is F into L, because it is F into S. F is the friction force and L is the length. Right. So now what is the value of F over here? It is mu into N. We discussed this in the forces chapter, how to find out the friction force into L. Now what is N? N is equals to M into G into cos theta. That also we discussed in the forces chapter into L, and that is the E loss. So what is happening now? The energy at A, which is equals to mgh, is equal to the energy at B, which is just what? Half mv square. When the block will reach at the bottom, it will only have kinetic energy. Plus the E loss, which is mu mg cos theta into L. That is the loss of energy which is taking place. So when you want to find the velocity over here, m will cancel out. What is the velocity now? Okay, you can do the calculations. Basically, it will be 2gh minus 2. Okay, so 2 I can take common. Gh minus, so what do we have over here is 2 I can take common. It will be gh minus mu g cos theta L. And g also you can take common. That's no issue. Okay, and under root of that will give you the velocity at the bottommost point. Understood, right? And obviously, like with this L also can be converted because we have h, so you don't have to introduce another variable. That things you can easily, I think, solve that. So this is the idea over there. Whenever there is a friction, we have to consider the loss in the energy as well. That's it for today's session. Okay, in the next session, I will give you one very good question which will involve all of the concept which we did, the work, power, energy, like how to conserve the energy. Mostly it's basically conservation of energy principle only. And also I will introduce you to power. What is power and what is efficiency, and what type of questions you can expect from power chapter. All right, these are like a very basic concept and very basic questions which I'm giving you right now. Okay, questions are very typical and a lot of different concepts. Obviously, I can only tell those concepts when we do a regular session. In this trial classes is a limited time, right? So I cannot teach everything to you. So please do book a free trial class. Make sure all your concepts get clarified, and we will meet in the next session. All right. So see you. Bye. Thank you.